Hi, my name is Jonathan Bukhara. Tonight I want to talk to you about strong types. The journey I'll be proposing to you starts off with a simple example that shows how strong types can be useful in C++ and actually a definition we can give to strong types. Next up, we'll see an implementation of strong types. And thus far, that would be quite classical work. And then we'll see how strong types play well with units, and then a very practical, real-life usage of strong types, which is passing them by reference, which is quite rarely treated, I found. And then we'll see how to do strong typing over generic types, how to recycle primitive types functionalities, and why we would want to do that in the first place. And then we'll finish the talk by the dreaded question everyone asks about strong types, is how much do I have to pay in terms of performance to get all the benefits that strong types bring? This should take a bit less than 45 minutes, which hopefully will leave some time for questions, and then we'll go to dinner. Just one more thing before we start is, if you do have questions, then I'll ask you to hold them off until the end of the talk, so that we make sure we've got dinner on time. But if there's something that you don't understand, it means that I haven't been clear enough, so please interrupt me, and I'll be more than happy to try to explain it better. Right? So let's dive in. Let's start with a very simple example of how to model a circle in C++. Right, so I've got a circle which has a radius, which is how I can construct my circle, and the circle, quite expectably, does circle-related jobs like computing area, computing perimeter. So that's a very happy and peaceful circle class, until there's a major disruption in the life of that circle class. Is I've got a new specification that says I should be able to build a circle from a diameter. Right, a diameter is twice a radius, and there is no reason why we shouldn't be able to build a circle from a diameter if we can build it from a radius, right? So I can add a constructor up there that takes the diameter, converts it into a radius, and then the circle keeps on living its life. Except, obviously, this doesn't combine, right? Because I've got two constructors that are ambiguous. If I call circle with a number like 10, then the compiler doesn't know which circle, which constructor I'm talking about, right? So that doesn't compile. Well, that's simple stuff. One thing that's interesting to know, though, is that I was able to add a setter easily, and that compiles, right? What makes the difference between the setter and the constructor is that the setter has a name. And that's the whole purpose of strong types that we will see tonight. So, how can I fix that class to make it accept diameter? Before jumping into strong types, I want to show two possible implementations that do the job, but that I don't think are as adapted as strong type for that type of problem. The first one is the builder pattern. A builder pattern consists in having a class which has a responsibility of building another class. Like, I've got a circle which I want to build, and I'm using this extra class which is a circle builder. The thing with that builder is that it offers method like setting a radius, setting a diameter, setting whatever, and I can chain up, if I wanted to, the passing of parameter. Like if I had a color or a thickness or whatever, I could chain up the width. That does the job, right? Because from that point of view, the compiler knows which I'm talking about, between the radius and the circle. Although it does the job, there are several drawbacks with that implementations. The first one is that if I somehow forget to pass all the parameters the circle should have, like imagine I had to have a color in a circle, then with that implementation, I don't have an error at compile time. Right? I could potentially check when collecting the circle from the builder, I could check if the circle is at everything, and if it doesn't, maybe throw an exception and do something at runtime. And that's a problem, because that would be found at runtime while the mistake has been made while actually coding. So it should be stopped at compile time. Another issue that's nowhere as important is that this builder could incur a copy. When taking the circle off the builder, it may be a copy. Like in theory, there is a copy, although this copy can be elided, probably, by the compiler. Let's see a second implementation that's based on another technique that's more classical to C++, which is tag dispatching. Tag dispatching is found in code to solve that problem of diameter, and other problems as well. The purpose of the tag is to identify which prototype I'm talking about. So to differentiate the prototype, I do different types. Right, so I create a new type, that means a radius, and I create a new other type, that means a diameter. Right, and I've got these new two prototypes, one with radius and one with diameter. These types up there, they just have this purpose, so they don't do anything per se. So that works, right? Calling side is at the bottom, and that just works. Like you state your intention that way. But it's probably better than the builder in that case, but still not that good. First drawback is that this is arguably weird. Right? Maybe you agree with that. It's much easier to agree when there are several parameters. Right? You really don't want to double up the number of parameters past the construction to a circle just to say what you mean. Right? So tag dispatching is okay, but not that good. Right. Let's move to strong types. The idea behind strong types is to create a new type that's meant to be the underlying type. Like I'm creating this new radius type that's meant to mean a double, although it says that it's not just a double, it's a radius. Right? The type doesn't do much. It can be just built from a double, and you can just retrieve the double from it, and that's about it. And then I create a new type that's called diameter, and that means it's double, but it is diameter, so it's not the same thing as a radius. Using these guys into code gives that. Right? I have this new prototype. That's completely okay because these are two different types, radius and diameter. So when I'm constructing the circle, I can choose whichever, and that's all good. That's all clear. That's not ambiguous to the compiler. So that's the idea behind strong type. This leads us to give a definition of strong types. A strong type is a type, like the type radius, the type diameter, that's meant to replace another type, a more primitive one, like double, in order to add meaning to this type, saying that this double is a radius or a diameter or whatever, right? And it does it with its name, which ties up with what we said with the setters that have a name. Going back to the implementation of radius and diameter, there's something that's really striking in that slide. Is that these two classes look awfully similar. This screams for being generalized, and that's what we are going to do in implementing strong types. Before doing that, I want to make it clear that this is not new, not at all. I certainly haven't invented strong types, not at all. There are there have been quite a few attempts to use strong types in C++, be that in libraries or in proposal for the language itself. The most famous one may be in Boost. Right. All these have are tackling different problems with different solutions, and they all have different problems by themselves, tackled by different solutions. So I want to show you everything that follows, because I think it is somehow different from all these. It has some commonalities, of course, but there are some things that combine them or are actually new, in my opinion. I haven't done this on my own, obviously. I've received much help, particularly when preparing for this talk, from my colleague Mathieu, Kevin, Raoul, Jeremy, and Quentin. Thank you, guys. Back to the generalization. If I take the radius and the circle and see what's in common with them, I get approximately that, right? If I replace double by t to make it generic, I get approximately that. Approximately, because there are just a few more things in that one which are dealing with constness, right? So if I have a const strong type, then I could get a const underlying type, and dealing with R value references, right? In case I receive a temporal, which can happen. Right, that's just a generification of strong type, which I'm calling name type because that's the whole purpose of it. To instantiate a name type like radius, I can just use that name type class and passing double as the template parameter. So that's all good, and we're all happy, except for one thing. When I use diameter, that doesn't work. I mean, it actually works, it compiles, but we're back to square one. You probably see that, right? Because if I do radius and diameter, these are just the same type, and we're back to the constructor, which are ambiguous, and that's all for nothing, right? So we want to keep that syntax because it looks like a tab def, and that's what a strong type really is. Like, it's a double, but with the names. That reads quite prettily, I think. But we want to specialize to make radius different from diameter. One way to do this is using phantom types. Hence the phantom. A phantom type is a type, a template type, that's there in the class up there, that's not used in the implementation. In that sense, it's here, but you can't see it. It's just like goes, right? So if I provide a different phantom type, then I've got a different type, right? So I can just do that, create a new type for radius, a new type for diameter, just for the sake of creating them, these guys, and that's it. It looks like a type def, but not as much as it did before. One nice thing that we can do with C++ is including a forward declaration of the tags within the using, which looks like that. And that looks better, I think. It's not as nice as the first one, but I think it's okay. I mean, by using them, I found it's quite okay. Now, how can we use this? This example has come from my colleague and friend Frederick, who has helped me with that topic as well. This is in UI, somewhere in testing maybe, and I'm trying to describe a position in a table with a row and a column. I have the declaration somewhere, like in set position, which one's the row, which one's the column. It's somewhere. I can't find it. I can, but sometimes I get that wrong. Like when I write my code, I get that wrong. When I read code like that, I have no idea which one's the row, which one's the column. So I have no clue whether I'm there or there, which can be problematic. With the same thing using strong types, having a strong row and a strong column, which are just ints really, but with a tag, with a name, then I can actually say which one's the row, which one's the column, and I know. Like if I get that wrong, there's a serious problem with me, and the compiler will stop me anyway. Talking about compiler, strong types are something that's quite important in the topic of expressiveness. It's about expressing our intention in codes for two kinds of persons. The first one is other developers, humans, co-workers that will read that code and that we know which one's the row, which one's the column. And the other one is the compiler itself. It's a good thing to express its intention to the compiler, because the compiler can stop us if we do something that's different from the intention that we stated before. So that's the thing about expressiveness, and strong type are a powerful tool for striving for expressiveness. Right. Now that we've got strong types, let's see what we can do with them. One thing that's nice and that looks pretty is how we combine with units. By units, I mean like meters or miles or seconds or kilograms or whatever, like physical units. A unit, like a meter, it's a double, really. But it's a meter as well. So we can say that it's a double with a name on the top of it that says it's a meter, right? And then there's something that's nice in terms of syntax, is using this operator that defines user-defined literals. Right, so that operator, quote, quote, means that I can use a literal, like 10, and append it, that thing, underscore meter, and then I get into that code. And I say that this code builds a meter from the inside novel. And then how can I use that? I can just build that class, a rectangle, change a bit from the circle, with a width and height, and a width, it's expressed in meter, but it's a width. It's not the same thing as a height, which is expressed in the meter, but it's a height, right? In the interface, it's not the same thing. So I'm using strong types here, once again, with width and height, always with the tag, and then combining all together, I get to that kind of expression, which looks pretty, I think. One thing that you can wonder is why I haven't used the operator quote quote also for width and height, and I intended to do that at the beginning. But the thing is, when you see this, it's quite natural to have the unit after the number, and then saying that this whole thing, 10 meter, is a width, right? You don't really want to have 10 underscore width, right? So I think that's what comes out best here. So that's it for strong types and units. Right. So far, it's been quite pretty. Now, by using them in real code, there's this topic that came up and which I didn't find an existing solution. Maybe there are out there, but I just couldn't find them. It's parsing strong types by reference. Actually, when you think about it, going back to our strong type, if you're building this strong type with something, then you're actually making a copy, right? Because the name type it stores a T, and then it makes a copy of the in its constructor, right? So if you're using strong type, then you have to have a copy, you don't have a choice. And that's a problem. Why is it a problem? There are two reasons, at least two reasons why it's a problem. The first one is that maybe you don't want to pay for a copy. Maybe you don't care. Actually, most of the time you don't care. Like you have the 90%, 10% rule, you know, like you spend 90% of the code in 90% of the time in 10% of the code. So most of the time you don't care paying for copying, particularly if it's double, and then you just don't care. But if you have a bigger thing that happens to be at the bottleneck of your program, then you care, and you want to have some control over that. The second thing which I think is more important because you're likely to care more often about that, is that with a strong type like copy, you can't bind like a reference would bind to the argument you're passing, right? To illustrate, one last drawback is that often, not all the time obviously, but often, input parameters are passed to function by reference to const, right? Here in our example, we pass by copy, which is not looking like normal C++, right? You can pass by copy for native types like ints and doubles, but in the general case, you pass by reference to const, and you can't do that with it. We'll see more in a short while. Before that, I want to illustrate my point by talking about why it can be important to bind a reference to something you're passed. In general, you don't want to do that, right? If you're passed an object, then you don't want to bind over it because you don't have control over the life cycle of this object that came to you, right? So maybe you want to copy, really. But there are some cases where you do want to bind over it, and one typical example is found in the STL, and it's called backinserter. Backinserter is a function that builds an iterator, and that iterator is bound to a container, typically a vector, that can accept to be pushed back into, right? So when you assign through that iterator, the value you're passing is actually sent to pushback of the vector you bound to. Does it make sense? Right. So for example, the typical usage of backinserter is to append data at the end of a vector. Right. And in that case, you really want the iterator to take a reference to the vector. If you have a copy of the vector, then it's all for nothing because you're pushing in a vector that's just stored in your name type, but that's not the one you want to append to, right? So passing by reference may be important. So how does that work? Let's go back to passing by const reference and take the two problems separately. Passing by const is okay, right? Because we deal with constness over there. We can have a const reference to the parameter we are strengthening. But passing by reference is not okay, not at all. Because if we write passing by reference like we would do with a normal type, not a name type, then this does something that's completely different from passing by reference in general, right? Because you're still making a copy because you need to build the width object with something, and this something has been copied. So you can't pass them by reference just like that. So there is something that needs to be done. One thing that needs to be done is using a new name type. At first, I didn't find a way to do differently, and so I decided to create this new name type, ref. That's main. That was meant to strengthen references. As in, name type ref of string would mean a reference to string. That's okay, that works, but that's not that pretty because it's a new component, and maybe you don't want that. So that's not the final solution. The final solution, it's really my colleague Kevin who helped me see it. It's Kevin. Oh, there it is. Thanks, Kevin. It's just to use the name type, but using a reference. Quite simple, right? Except it doesn't quite work that way. Because if you replace T in our name type by something that's reference, so let's call it tref, right? Then this constructor will be a tref ref. And if you've seen Scott Myers talking about that, then you probably know that that collapses as a tref, right? So we end up with a tref and a t const ref because a t ref, const ref is still a t const ref, if that makes sense at all. But at the end of the day, we've got a constructor that takes a const tref, and another one that takes a tref, and that's ambiguous. So that just doesn't compile. What we can do, and that's still an idea of Kevin's, is to just deactivate that when t is a reference. I mean, we know if it's a reference or not, because we're actually writing in code name type of string ref. So we know it's a ref. So we can surely do something about that and take that guy away, right? To take somebody away in C++, or somebody like a function, one thing that can be used is template metaprogramming, or spinae, in that case. I'm going to show it to you what it looks like, although it's not the purpose of tonight, so don't be scared if you don't quite understand all that stuff. The central piece here is enable if, that basically says enable that, all that, if t is not a reference. And it can't be t, it has to be something that's taken from t, because from the point of view of that constructor, t is not a template because it's something that's already known up there, so you need to have a template. Anyway, TMP is not really the purpose of tonight. Well, if you've got questions, I'm happy to take them anyway, but maybe after the talk. Well, the thing you have to understand to follow the rest of the talk, I mean the rest of that section at least, is by doing that, this constructor just does not exist if t is not a reference, so it can't be annoying while compiling, and that's all good. And that works. So the syntax, the resulting syntax though, deserves more attention. Like we saw, I can't just write a tref with the ampersand, right? So I have to use my ref. So say that I have a name. A name is a strengthened string, right? Like the name of somebody, and I want to pass a strong type representing its name. So I'm just writing name ref is name type string ref with the tag. Right. Then in the API it's approximately okay. I mean, I think that's the best I can do at least, because it reads like name ref. Right. I would have loved to write the native ref, but I can't. The curious thing though is that at call size it has to be a name ref. So is that a good thing or is it a bad thing? I think the answer is it's kind of both. It depends. If it's a reference to not const, which is not the case here, then it can be seen as a good thing to show it's a ref, because it can be modified by the function, right? Taking by reference to not const. Some people go a long way in their code to show that something may be modified by taking a pointer or instead of reference something. Also, some languages I gathered have taken that choice, like C#, to express that it's a reference when you're passing it by reference. But when it's a reference to const, then you don't really care here if it's a ref or not ref. So that's it really. And that's it for references. A completely different topic, so we're moving away from references, is to do strong typing over generic or unknown types. And by unknown types, I'm thinking about lambdas. So let's consider the following example. It's actually a real life example. It's a true story that happened to me. It is this code I wrote initially was to do something with the STL, by comparing sets together. So I've taken all of the STL code away from that because that's not the topic of tonight. But the thing that we need to know to understand the purpose of this section is that this is a function that accepts two functions. One for, say, comparing things, and one for aggregating things together. Right? And I want to pass two functions in the form I like, be that a function or lambda or function object or whatever. So I can use it with a lambda, for example. So I'm passing this function that does comparisons in the place of compare, and another one to aggregate things. That's okay. That's actually very, very good. Except I can swap them around, and that's not good at all because it compiles. Right? The compiler has no way of knowing that this should aggregate things and this should compare things. And they are just lambdas, and the template resolve with lambdas, with the type of lambdas, and that compiles. But that compiles that doesn't do the right thing. It's actually relevant for real life. Like, even if your functions are not taking void and returning void, if they are taking or returning native types like booleans or ints or whatever that are convertible to one another, then this can actually compile. But that's completely wrong, probably. So what we want to do, given all we've been through so far, is giving a name to these two guys, saying this one is the comparator, this one is the aggregator. Right? So we want to use strong types. So I'm going to define two name types. Right? The first one will be a comparator. Using comparator equals name type of what? That's the type of the lambda I want there. And I'm not supposed to know the type of lambda, right? So I've got a problem. I've worked a bit on that one and find some complicated solution, and in the end it turned out that the solution is surprisingly simple because the name type class is already templated, so we can just use it as a template and then use it in a template using declaration. And since we're building a template class comparator, particularly since we don't know the type of the underlying type, then we don't want to pass it, so we create this helper function, which I'm calling comparator, that returns a comparator with the right type. Same thing with aggregator, and how I use them here is just using them in the interface, saying that I'm expecting a comparator, which is templated. So now I can actually write which one's the comparator, which one's the aggregator, in case a human being or a compiler had the doubt, and if I swap them around, then that doesn't compile, right? Of course, comparator and aggregator have some commonalities, and we want to make something that's more generic, which is quite easy to do by just replacing functions by t, really, and returning a name type, right? If you're thrown off by this template type name t class, it is just a template parameter, except it's not just a type, it's a template, right? So this is a template that's taking itself a t, and that's template. For example, I'm passing comparator here, which is template, right? And so the final syntax for that, for the moment, is this, building name object for that. And that's for the moment, before C++17, because in C++17 there's this nice feature that the compiler is able to deduce the type passing a constructor. Right? It's got everything it needs to know that I'm talking about this type and this type, so why make me say it, right? So that's the right one compiles, the wrong one doesn't compile it, and that's how the world should be. Now, the strong type is strengthening a primitive type, like a double or an int. It may be argued that you want to reuse the functionalities of the underlying type in the strong type. The only way we have to do it so far is by retrieving the underlying type through the get.get method. At first, I didn't think that was useful to do more than that. I thought that would just bring more complexity. And then I saw a compelling example that was brought up to my attention by Frederick again, which is the STD Chrono library. STD Chrono, which is standard. We've got these types, minutes, etc., that represent durations, and all these are just ints. Well, you can tweak them to make them doubles or floats or whatever. But essentially, they're just ints, but with a name, hour, seconds, and so on. And these are different types, and this is actually strong types, right? And Chrono comes with some features that you can manipulate strong types a bit like you would manipulate ints that are behind them, right? So you can add seconds, you can compare seconds, and you really don't want to be forced to do a dot get on the first one and a dot get on the second one and build the whole thing back into a second to have an addition of seconds, right? So that actually convinced me that it would be useful to have underlying functionalities brought up into the strong type. Although you don't want all of it, right? Because there are some things you don't want to be permitted to do, right? You don't want to be able to multiply seconds together by mistake because it doesn't make sense. So you need to pick and choose what you want to take from the underlying type. How do we do this? Well, one idea is to use policies. This idea of taking away the different behaviors into classes of their kind and using inheritance, I've seen it somewhere on a blog which is funathan.net. If you probably know it because it's so popular. If you don't, you should check it out because it's amazing. But the implementation that follows is, I think, different enough so that it's worth showing to you. We can build these kind of modules for pretty much every operator that the underlying type supports. And the thing we would like to be able to do is to declare, when we declare a strong type, which functionalities we want to pick. Right? So ideally, I think, we want to get to that syntax, which is saying that a length, for example, is just a double, but with a tag, because I have to. And then I can say what a length can do that a double can do. And what's not here, like being multiplicable, for example, the length won't be able to do. That's really what I want. It turns out that it's actually much more simple than it looks. And we can do that just by using policies. Right? So we can take all the skills that we want the strong types to offer, take them into a variadic pack, and then derive from them, right? Because all these guys, like Adable and stuff, they offer operators like operator plus. So the name type will also offer operator plus. And the end client, which is us, doesn't have to inherit from a different thing. It can just declare them, which is, I think, so nice. This uses CRTP, by the way. It's implementation detail, so I won't get into it, but that's how it works. Last question, the dreaded question about strong types is, how much do I have to pay for using that? I mean, I realize it brings expressiveness to my code, but does it come at a price? So let's try it out. Let's make a test. So the test we will do is comparing what code is generated without strong types, so with the one that's generated with strong types. So I'm using a rectangle, right? I'm using a rectangle, one with native types and the other one with strong types. And the code we'll use to test it is basically ask the user for input and spit out outputs, right? And build a rectangle. Where would the cost come from? Well, probably by building these. Constructing a width, destructing a width, pushing a value, taking a value off the width. That may have a cost. Right? So let's test that. this is the assembly that's generated. As you can see, these are exactly the same. So this is zero abstraction cost. That's the holy grail of modern C++. We're basking in the glory of modern C++. We are so happy tonight, except this was built with Clang in -02. How does it look like if I do -01? It looks like this. So there's a difference. Let's try it with another compiler. Let's try it with GCC -01. Oh wow! That's the same thing. Expressiveness for free. How amazing! And GCC without optimization, then we have a difference. What to think of that? Well, first, if you're compiling with enough optimization, then strong types are free. Right. Now, if you don't, and some people don't, and that's okay. There's a difference. Now the question is, will this difference matter? Well, as we said at the beginning, there's this rule that says that you spend most of the time in a very small portion of your code. So if that strong types happens to be in that bottleneck, then you care, and maybe you can't afford expressiveness. But for the most part, you just don't care. So you get expressiveness, and it won't have an impact on performance. But what you're 100% sure of is that the code will be more expressive, and that has value. Before we finish, a few words. First is, as I mentioned at the beginning, I'm relatively young and very keen to learn, so any feedback on that is more than welcome. Right? We can talk about it over a slice of pizza, or talk about anything really, or online. You can find me on Twitter at Joe Bacara. If you want to see the code, you can get it on GitHub. Joe Bacara, I've named the project NameType, because it makes sense. And if I can bring anything more about expressiveness, which is such an important topic to me that I've dedicated my blog to it, then I can find you on my blog, which is called Fluency++, fluencypp.com. You can see article about expressiveness in C++. We can chat there. I'm always delighted to get in touch. Thank you.
Thank you, Jonathan.
Shall we have questions, or shall we hop to dinner? Yeah, Christian. Hey, look.
Just a remark for a question about this nice C++17 syntax that you don't have to specify the type and automatic deduction of the type from the constructor parameters.
Right.
It's a little bit discussed now. It's
Is it?
not 100% sure it will be in C++17 because some people try to apply it to the standard library, and by default it did not work well for many types. So I don't know exactly. I really don't know what will happen, but it's one subject that is a little bit not
sure.
Yeah.
That makes perfect sense. Thank you very much.
Okay, so that's maybe that it will be there, but you will have to write explicit deduction guides for it. So I don't know what will happen on this subject. And the second point is, what surprises me in your description, in your presentation, is that you are using strong types for two things that are quite different to me. One is, I'm sorry, I don't know the English word for it, grandeur, different kind of grandeur. I don't know what's the English for it. For example, for example, having a strong type for length that is different from a strong type for area, or for a strong type for duration. This makes sense to me. But having a strong type for width that is different from a strong type for height, I think it's a different subject. And it doesn't make that much sense to me, because, especially because we want many conversions between those. for this example with the radius and the diameter, we want, in many cases, we probably want to be able to convert from a radius to a diameter and in all direction, because it's the same kind of grandeur which is behind this. And we don't want to have conversion between meters and meters to the square, or between meters and so on. This doesn't make sense. But I think those two subjects are very different subjects. And in one way, the way you want to have these strong types for radius and diameters looks to me more like you want to have named parameters for functions. And I think it's a little bit, maybe it's a little bit different subjects than strong types. And collapsing them into only one subject seems a little bit strange to me.
I understand that. Well, thanks for the question. First of all, I've understood grandeur because I happen to be French, so you can talk to me in French, by the way. I understand that. Second of all, I do understand that. Maybe the length example is not that good. I understand what you're saying about the difference between, say, a unit, for example, and a parameter. Right, is that what you're saying? Right, that makes perfect sense. So, are you suggesting that it would be useful to be able to customize relationships between strong types, like somehow declaring a conversion function between a diameter and a radius? Would that be interesting?
I don't know, I've not thought about it, but even, for example, when you have, for me, there are three levels. One level is the order, which is, this is the length, this is the area, this is the time. The second level is the unit, which is, this length is in kilometers, this length is in meter, this length is in miles. Okay.
Everyone knows that.
Yeah. And so this is the second level. On top of grandeur, there is units,
right.
And then there is meaning. This length, which is in kilometers, is used for diameter. This length in kilometer is used for a radius. And as I understand strong typing for grandeur, I understand strong typing for units. I'm not sure about strong typing for meaning. That's on, maybe something else would be more useful for meaning, like name parameters or this kind of stuff.
Right, that makes sense. Thank you. Any other question?
Yeah, I had more like the same remark to do, that you could add some implicit conversion between, for example, diameter and radius. And then you can simplify your code because you can take just radius, and if you have a diameter, you pass it, and it converts automatically. I'm very happy.
Wow, yeah.
It's beautiful.
Yeah, thanks. Thanks a lot. Anyone question?
Just one thing, in your example, you still used a double inside of your class.
Yeah, right. Absolutely.
I think it's it means something that you are still using a double inside of your class.
It actually means something. Well, I try to explain why I made that choice, and you let me know if that sounds good to you, right? The whole purpose of strong types is giving names, because unnamed things may be mixed up, essentially. Within the class, I've got a member that's called width, it's double, and then another one that's called height, it's double. So within the method of my class, if I use width or height, even though they are not strong types, I can't really mix them up.
But you might still want units on this, and you might still want to be sure that inside of your class you're not adding meters with seconds.
Right, so it really ties up with your difference between meaning and units. Yes, having a width stored in meter within the class would make much sense to me. Any other question? Yes. Yeah, you do answer.
I'm just going to insist on the same point, which is that name parameters, even though I'm not very fluent in C++, but according to my understanding, also is a way to select a trait. So the longer you keep the named information, the better it is, so you don't mix within the class the same thing. My feeling is that we should build named, wrap the type within a new type,
right.
and then keep it this way until the end, unless you need to extract the value. But on the very
Yeah, that makes perfect sense. That in this case too, I will try to explain why I made that conscious choice, and you let me know if that sounds good to you. Sometimes you don't want to keep a strong type. One example is when it has meaning. For example, width and height. Because sometimes a width is not a width anymore. Imagine you want to transpose your rectangle. Then the height becomes the width and the width becomes the height. So you may not want to keep that all the way.
That would be at the very moment you want to swap the dimensions that you extract and then wrap again in the other name type.
Yeah.
I don't feel the need to extract it before the need to swap it. That's just the point. I understand.
Fair enough. Thanks. We had
I just have a comment on the other comments.
Okay, that's
So
Mita
meta.
commenting.
Yeah.
So meta.
So basically, I'm not sure if something like named parameters will solve the problem. To me, the issue here is that what we want is name things to give them meaning, so that the compiler helps
Right.
finding issues.
Mhm.
So with named parameters, you will have to make sure that if you have named parameters in C++, you need the compiler to force you to name everything.
By adding name,
Yeah.
name, native.
Yeah, we will get back to having name types explicit.
Natively?
And what I mean is that you need name parameters to be checked. So you have to associate the value that you pass to the function with the name
Okay.
anyway.
Okay.
So that's just a second.
So that would be an improvement on the language itself,
Yeah,
right?
because I read most name parameters proposals, and I think there is only one that tried to set up a way to force the caller to name the parameters,
Right.
while the others wanted just to allow the callers to name parameters. But it's important to know that if you want to fix this problem, name parameters is not always trying to fix this problem, it's trying to fix a convenience. And if you want to fix this problem, you also need to have the checking of the name of the parameter first.
Right.
Yeah. So that's not that simple.
Okay. Thank you. Do we have any other questions? Yes, at the back.
You have the right the print the const name ref so the class name ref, but the const in itself has no real meaning in the declaration, only of the definition.
Why is that though?
As it is not a real ref, it is like you can write print const int, but it has no meaning. It is unrelated with the definition.
But
Where in the definition we can have without the const and then modify.
but if you have a const name ref, then it means the name type is const, right?
There is a distinction between the declaration and the definition.
For the function.
It is not a real ref. It is not a reference.
Right.
It's just a const object.
Yes.
And in the declaration, you can get the const, and in the definition remove it as it is.
I'm not 100% sure, because if you call .get on the parameter, then it would go into the const get method, right? And you get a const tref, wouldn't you?
Can you show the code?
Certainly.
You can have this declaration, and in the definition you can, but even if you don't want, remove the const.
Okay, thanks.
we had one
Any
last
other-
question somewhere?
Oh, do it anywhere.
So we have a use case at Tanker of name type. We use asymmetrical keys, and we have private keys and public keys, and we really don't want to mix them up. And
Yeah.
it's not only about name parameters.
Right. Thanks. Thanks. That would be a very bad thing to mix them up. And another bad thing that happened while mixing type was, sending that rocket over Mars. You know. And that story, right? The Mars. What? Yeah. Another question. Yes.
How do you mostly use it in your personal work or professional work?
I have used it while using ranges. You know, ranges like the thing after the STL, like considering a range is instead of 2 iterators, right? That's another thing. I've tried to build some range adapters, which are the things that are found in the range v3 library from Eric Nibler. Like you can pile up transform and filter and all that kind of thing. And I've tried to develop new ones and to make these guys wrap ranges. Then sometimes I had two constructors that look the same, like passing a begin and an end, and then I had to use strong types to differentiate. I also had the problem of references in that case because when you're adapting a range, then you may want to build on that range and take a reference over it, otherwise it doesn't work in some cases. So that's one example. But maybe someone has used strong types in its code and wants to share. Yes?
I used something similar to your name type, but I used an enum instead of a parameter.
Template, phantom parameter.
It was me to declare classes. So just have an enum and many. It was for ID, to specialize IDs in the things and to avoid to be confused about the IDs and to assign an ID to another ID variable, to be confused about that.
That makes perfect sense. Yes. Again.
It was just also a small idea that phantom types can be used regardless. Besides just wrapping types, such as you could convey some information regarding the precision of some integer you get, like the numbers pad, the third. That doesn't make some sense because I got it from this position, and convey that with the phantom types.
Yeah.
Without wanting to, so phantom types can also.
Right.
Mix as a comment, and also a way to add some extra information, so that's kind of techniques that can go in pair with, as fact, to wrap types and name types, so that
absolutely.
that go by pair. And along some of that stuff.
Yes. Phantom types are so useful. I've seen a third example from Quentin, who's probably not there tonight, which is a shame. He uses them to store state in the type to force his objects to go along a workflow. Like every step of the workflow takes the basic object but templated on a phantom type that is a state. So you can't play around and do the wrong step before the right one. So phantom types are cool.
A kind of transformation.
Sorry?
Like you have the initial type that corresponds to the initial state, something like that.
Yeah.
And you pass it to something and it returns another type, but it's actually the same data.
Exactly.
Precisely.
Okay.
Yeah, to protect SQL requests, for example.
Okay.
Any other questions?
Yeah, I think we're running out of time, so I just take the last question personally. So, I had privilege of time, huh? Okay, so I was wondering, I see that you benchmark 2 of the maybe 3 big compilers today, so I wonder that since we maybe have a special guest tonight, you didn't want to offer anyone, so my question is, why didn't you bench Oracle Sun Studio?
I wanted to
so good he didn't want to scare people.
Alright, that was just a joke, guys. The pizzas are already there, so don't let them get cold.
Thank you.
Thank you.